Hello everyone. So today we will start with the first chapter for CCNA, Cisco Certified Network Associate. In this chapter, we will go through the various network fundamentals that are necessary to start with the networking course. So let's begin. First topic: internetworking. In this topic, I will give you a high-level overview of how the network elements work. What are the various network elements that we have, and a high level explanation of how they work. So let's go to the diagram. Okay, so the first element that we have here is hub. So hub creates a single broadcast domain and has a single collision domain. What we mean by that, I'll come to that when I go to the diagram. Next we will discuss switch. By default, switch has single broadcast domain and multiple collision domains, that is per port one collision domain. So why by default it's single broadcast domain, and how can we create multiple broadcast domains in a switch, that also we will discuss later. Then a router, which is a device that will perform layer 3 lookup and forward the packets to the appropriate next hop. So let's take a high level view of how all the things work. First we will discuss about hub. Say for example, in this instance we want PC1 to communicate with PC3. PC1 wants to communicate with PC3, for example. So PC1 sends a packet towards the hub. Now hub will replicate this packet, this frame, to all the interfaces except the interface on which it arrived. So it will flood it here, and also towards the switch. Now among these, the PC2 and switch will discard the frame, and PC3 will accept it. So this frame will be accepted by PC3 and the communication would be successful. So here what we saw is that the hub will broadcast whatever is received on one port to all the other outgoing ports. So this is the reason we call the hub as a single broadcast domain. And why do we call it a single collision domain? That's because, say for instance, when PC2 transmitted a packet, a frame, PC1 transmitted a frame, sorry, and at the same time, if PC2 transmits a frame, then this won't be allowed because there will be a collision. And how to avoid collision and how does the hub avoids collision, that we'll see later. But for this case, when PC1 and PC2 transmits together and the receiving element is the hub, then this will not work. A collision will be caused and the data will be corrupted. Okay, so that's why the hub has a single broadcast domain and a single collision domain. Next we will discuss about the switch. Switch also has a single broadcast domain. So what do we mean by that is, for example, let's say PC2 wants to communicate with PC4, for instance. PC2 wants to communicate with PC4. So PC2 sends a packet towards the hub. In the similar manner, hub will broadcast this traffic through all the other ports that it has received it, except the port where it received it. Among these, PC1 and PC3 will discard the frame, and when it goes to the switch will again broadcast it on the other interfaces. It's again a layer 2 device. Now in this case there is one catch, that this switch that we're talking about has broadcasted the frame, the purple color frame, to all the other outgoing interfaces. We can avoid this by doing something that we will discuss later. So we can have something called as VLANs, and we can divide the broadcast domain of a switch to restrict communication to only certain segments. Secondly, switch has the capability of learning. So MAC learning, if the switch has already learned the MAC address of PC4, then it won't broadcast it to all the outgoing interfaces. Rather, it would send the frame only from the segment through which it has learned the MAC address of PC4. That is why this hub. So this way the communication will reach through PC4. We have considered the case where the switch MAC table is not having the entry for MAC address of PC4, and it is broadcasted to all the outgoing interfaces, then to hub, and hub, following its broadcast rule, has broadcasted to PC4 as well as other interfaces if it has any. So ultimately PC4 receives the packet and accepts it, while all the others will discard the packet. This hub as well as this router, they will discard the packet. Now going to the router, when will this communication go to the router? Now let's say we have a remote location or a remote host located at some XYZ location, and the host in PC4 wants to communicate with it. For example, let's say in this domain, which is some another administrative domain, for example some another company, and there's some host that wants to communicate with this PC4. So in this case, what will happen is the routing or the communication will start, let's say for example from this host. This host will send packet to its own router. It will be having a router at its own end. So this host will send packet to its own router. Let's say R. This router will hand over the packet to our router, that is the enterprise networks border router. This router has received a packet on its layer 3 interface, so it will perform a layer 3 lookup and perform the routing function towards this side. I should have used a different color. Let's say this color. So we received it here, and router perform layer 3 lookup, so received it here. Now the switch, when the switch has received the packet, the switch will check the destination field for the packet, for the received frame, and it will again send the packet to PC4, via which it would have learned the MAC address. So the destination MAC would be checked and it will be sent to hub, and via hub it will flow to PC4 as usual. So this is how the communication would take place. And at this point, we know why hub is called as a single broadcast domain and a single collision domain. And at switch, now let me tell you why we call it as multiple collision domains. So the collision domain at the switch will be one per port. So let's say for example, these are the ports that we see. This is the port. So one per port will be the collision domain on the switch. These are the ports 1, 2, 3, 4. So there are 4 collision domains and 1 broadcast domain. Switch itself is 1 broadcast domain and 1 collision domain. Now how can we divide the broadcast domain of a switch? That we'll see later. So till now we have seen the hub, the single broadcast domain and single collision domain concept, switch, and why it's called a single broadcast domain and multiple collision domains, and the router, the routing device, that is which works at layer 3 and performs the routing lookup. Next, there are few other devices which will also be part in the enterprise networks today. So you can see firewall. Firewall most probably would be connected to this switch. Let's say for instance this way, the firewall would be connected to the switch. Let's say here. Okay. So we'll have a firewall here, for example. Now what's the function of the firewall? Now when packet comes from the outside network by outside network I mean, for example, say this domain here. From outside network, when packet comes inside to our domain, we need to have some security checks so that we can take care of some attacks or unauthorized access. So this router will forward the packet to the switch, which would be as usual. The switch would then forward it to the firewall, and then from the firewall, after performing the security checks and policies, the packet will be handed over to the switch again. So if there is any suspicious packet or suspicious data, the firewall will drop it there itself. So it will not enter our core enterprise domain. This firewall will play that role of security and policies. Next is access points and access wireless controllers. So access points are nothing but used to expand the access domain, the collision domain of a switch. For example, let's say this switch has an interface. This is the interface of a switch, and 1 minute. Okay, so this is the interface of a switch, for instance, and we have connected an access point here. Okay. So this access point, various devices, say for example PC1, PC2, PC3, PC4 have WLANs in them, that is wireless LAN, and they can connect to this access point directly without this wired terminations on the hub. So they will latch directly to the access point and then to the switch and go outside of the enterprise to whatever they want to communicate. For example, Facebook or Twitter, whatever. So yes, the access point is used to expand the collision domain. This one interface is the collision domain of a switch, and we are expanding the collision domain via the access point to all the other devices. So other devices can latch indirectly to the switch, but without the legacy wired terminations. In the wireless controllers. So wireless controllers will be used in case where we have a large number of access points. Again, the wireless controller can be connected to a switch. Let's say for instance, here we have a wireless controller connected. So wireless controller So the function of this wireless controller would be to control the various access points that would be connected across the enterprise domain. So here I have shown one, but there may be hundreds or thousands of access points connected in an enterprise domain, and we can use few wireless controllers to control all those hundreds of access points. So configuring policies and configuring various schemes on the access point can be done through the centralized wireless controller itself. So this is all about a high level overview of the various networking elements and how do they function. And the most important in this point was the broadcast domain, the concept of broadcast domain and collision domain. Let's move to the next point, the most important point to start with. Okay, the OSI model. So the OSI model provides a framework for the communication protocols and the communication between two elements. So that protocol has to be followed and is followed. So in the OSI models, we have 7 layers: is physical, data link, network, transport, session, presentation, and application. And what are the functions of these layers? Then how do we see them when the communication is exactly happening in a network? That I'll tell you in the succeeding sections. So in the first slide, we'll cover the functions. The first layer, it's the physical layer. In this layer, we have a stream of the bit stream. So basically, the physical bits that will be carried over the cable, the wire. So those comprise of the physical layer. Next layer would be the data link layer. At this layer, we would perform few functions like error detection and flow control. And this data link layer is further divided into two sub layers. So that is logical link control layer and the MAC sub layer. So here the data link layer, which is divided into two sub layers, let's say for instance this has the MAC layer and the logical link control layer. So these are the two sub layers of the data link layer, LLC, logical link control. So the MAC layer is used to identify the layer 2 devices in the network, the physical devices. Each device is given a unique identity. So that's what the MAC address, the MAC layer would be used for. In the logical link control layer, this will be used for the logical separation of the layer 2 devices.